this is Himabindu from the Department of CSIT. So today in this video I would like to explain about the concepts called regular expressions and finite automata. So here the word we already discussed about how to define the regular expressions and what is the difference between finite automata and what are the different types of regular expressions we have and what is meant by regular languages. We already discussed in the previous videos. So here how these two are related, how we can convert the given regular expression into a finite automata and finite automata to a regular expression we will discuss in detail. So before going to that one, first what is meant by finite automata. So in the previous videos we already discussed about the finite automata, which is we have 5 types of finite automata. One is with output and without output. So let me briefly explain. So finite automata. So with output we have with output and without output. So these are two types of finite automata. So in the two types also, this without output, with output we have Murray and Millet missions, and here without output we have 3 types of finite automata. One is DFA, deterministic finite automata, and NFA, non-deterministic finite automata, and epsilon NFA. Epsilon non-deterministic finite automata. So these are all the different types of finite automata we just discussed in the previous videos. So here what is meant by finite automata. So finite automata is used as a recognition of patterns. So it is used for recognition the patterns. So in the patterns, the letters we are having some patterns. To match that patterns we are going to use this finite automata, and it takes the strings of symbols as input. So here without output. So initially for this any finite automata we need to give one input string. So that input string, based on the input value and transitions, we can construct the finite automata and state according when the required symbol is found. So here whatever we are searching for the patterns, we just found that string, the transition, it is a successful transition. So this is about the finite automata. So what is the definition of this finite automata? So generally either NFA or DFA or epsilon NFA, we have this finite automata with a 5 tuples. So here one is a Q. Q is nothing but a finite set of symbols, and sigma is nothing but the alphabet which we are going to form the strings. And next delta is nothing but a transition function. So for the input symbol, we are giving one input symbol to the one state. After reading that input symbol, it is going to the another state. That is nothing but entire process is nothing but a transition. So the transitions are all based on the languages we are going to construct. And next Q naught is the state what we are starting, and that is the initial state named as an initial state. And F is the finite set, or F is the final state. So F is also not only a single state, maybe there may be a 2 or more final states for the given languages. Based on the language, the states are also changed. And how many types of finite automata we just discussed. In that one we will discuss briefly about the DFA and NFA, deterministic finite automata and non-deterministic finite automata. So DFA refers to the uniqueness of computation. So here uniqueness is nothing but here for one state, here we are taking the input state. So initial state is as a Q naught, and for one single input it is reaching the one state. So it is reaching this is a uniqueness. So for this input symbol from this state, it is going to only one state. So this is the uniqueness. We can say that it is a uniqueness. So, and here the mission will go into the one state only for a particular input character in a DFA. This is about the DFA. So DFA does not accept the null moves. So here this DFA does not accept this null moves. And next, non-deterministic finite automata. So here non-deterministic finite automata, so which is here where for the DFA it is a uniqueness. So for one input it is going to the only one state. So that is the opposite to the NFA is opposite to the DFA. So that is nothing but, so for one input it is going to the multiple states, that is a non-deterministic finite automata. So for NFA transmits any number of states for a particular input. So based on the language, we are going to construct NFA. In that language, there may be one or two more states for the single input. So it can accept the null moves also, like null moves also accepted here. So this is about the two types of finite automata. We have DFA and NFA. And coming to the regular expressions, so regular expressions are expressions that describes the language accepted by the finite automata. So here the language accepted by the finite automata, it is mostly efficient way to represent the language. So any language we can represent in a regular expression, so it is a basic definition of this regular language expression is nothing but, so for any kind of language, any regular languages, we can easily describe the language in a regular expression. So the language accepted by some regular expressions are referred as regular languages. So to which language we are constructing the regular expression is nothing but a regular languages. So the regular expressions are used to check and match the character combinations in the string. So here whatever the characters are there, we have to compare that, and the string searching for that algorithm uses this pattern to find the operations on the string. So this is about the matching pattern. What we can say, the regular expressions are used to match the patterns in the string. And sigma is an alphabet that does not the input symbol denotes the input set. So here this sigma, which is we already discussed sigma, which is nothing but input sets. So how many input values we have, those are all comes under the sigma value. And the regular expressions over sigma can be designed as follows. So here, so pi is also a regular expression. So this regular expression, so there are properties of regular expression. So in that properties, so to which languages we are calling as a regular expression, in the sense, first, only the null value is also accepted as a regular expression. So RE here we can write it as a RE is equal to null. And next, epsilon. So epsilon is also a denotes the set. So empty set, this is a empty set, and this set which contains epsilon symbol as an input. So this epsilon is also a regular expression for this point. So second point says that, so even epsilon symbol is also having the regular expression. And for x and sigma x is a regular expression and denotes the set of x. So x is nothing but, so here based on the input values except this pi and epsilon, whatever there as a set, so set of regular set which contains the x value, so this x is also a regular expression. So these are the three conditions over the regular expression. So first one, which is represented the pi or empty set, which is also a regular expression, and the second one, epsilon symbol, epsilon input as a set, regular set values, that is also a regular expression. And the x, so except this pi and epsilon, whatever the values are there, those are also called as a regular expression. So this is about the regular expressions. And what are the operations we have for the regular language? So here, based on the regular expression languages, we have three operations we have. So one is a union operation, the second one is the intersection operation, and the third one, clean figure. So here the union is nothing but we need to combine what are the whatever there in the two regular expression values. So here whatever the set we have in the two types of regular expression, so that two sets we need to combine together and write it as a single regular expression. Suppose here a star is there and a plus is there. So these are the two regular expressions. So this is one regular expression and this is one regular expression. So if you combine these two, we'll get a regular expression, that is a star union a plus. So what it indicates, in this two union part we will get a star. So this a star is also a regular expression. So this union operation which leads to the regular expression as a result. And intersection. So intersection is nothing but we need to take out the common things. So here for the same example, we will take this regular expression 1 and that is a star, and regular expression 2, that is a plus. So if you intersect these two things, that is intersection of R1, RE1 and RE2, we will get the regular expression, that is nothing but a plus, we will get a plus only. So whatever the common thing is there, only a plus. So here epsilon is there, here not epsilon is not included here. So that we will get the result as a plus only. And next, clean closure. So clean closure of one regular expression 2, that is nothing but a plus whole star is nothing but also it is a regular expression a star. So this is 0 and more occurrences of the language R. So R star is also a regular expression. So these are the operations which we are going to perform, on the regular languages. So here this is a operations, interunion, intersection and clean closure. And what is the relationship between the finite automata and regular expression? So here is the simple thing when we are going to discuss about what is meant by regular expression and how we can convert it to a finite automata and how finite automata to a regular expression. In this diagram, so if you have a regular expression as an input here, so regular expression as an input here can be converted into a NFA, epsilon moves. So here the regular expression, so here I will divide these two parts, regular expressions to finite automata and finite automata to regular expression. So here we have a two types, so that we can convert one form to another form. So here in the regular expression form, so first the input is regular expression and here FA is nothing but finite automata. This regular expression can be converted into a epsilon NFA. So epsilon NFA first, and then we will convert this into a epsilon without epsilon NFA, and this NFA we can convert it to a DFA. So DFA we can also convert it to a DFA. So this is the regular expressions to finite automata. If we have only finite automata, if we want to convert the finite automata with only NFA, so we can stop here. And if you want to DFA, again we need to convert the given NFA to DFA. And coming to the FA, finite automata is an input and we need to convert it to a regular expression. First we need to take these two finite automata. We have two types of finite automata. So one is the finite automata with DFA and NFA. So DFA and NFA. So that first we need to convert it either NFA or DFA and we will combine it together, write it as a regular expression. So this is about the relationship between, so we'll get the deterministic finite automata which is converted to a regular expression. So and here this deterministic and NFA also we can convert it to a DFA, regular expression. So this is about the relationship between the regular expression and finite automata. So first we are giving the regular expressions as an input. It is going to convert it into a epsilon with the epsilon moves, so that we can convert it to a without NFA, without epsilon moves, and we then convert it to a DFA. And next, coming to the finite automata to regular expressions. So finite automata, which is an input, we can convert it to a DFA and NFA. So based on the values, we can construct these two, deterministic or non-deterministic, and then we can directly convert it to a regular expression. So now we will see how to change one form to another form. Suppose that is, if we are giving as a regular expression as an input and we need to convert it to a finite automata. So we will see first given input as a regular expression and we will convert it to a finite automata. So these are the examples what we are going to construct as a finite automata. So here pi is there. So pi is nothing but empty set. So this empty set, it is having nothing, no values. So that how we need to convert it to a finite automata. So finite automata, which is having the initial state, that is nothing but only, there is no final state. So simply represent it as a finite automata like this. For the pi symbol, we need to write like this. And next, for the epsilon symbol. So epsilon symbol, the empty set which is having the input value epsilon, and next with the epsilon symbol we will reaching the final state. Only we are having the only one input symbol, so that we will write it as a final state. So giving as a epsilon as a final state. Epsilon as an input symbol, it is reaching the final state. And coming to the A. So A is nothing but it is having the value A, and here we'll write it as a, so initially we have a Q naught symbol, and for Q naught, if you are giving A as an input symbol, it is reaching the final state, that is QF here. So A is represented like the finite automata. These are all the finite automata. So finite automata. So this is a finite automata. And for this A plus B, so what are the input values we have? A comma B. So set, so regular expression which is having the regular set. So based on this set values, how many input symbols are there? So here A plus B is there. So here from the Q naught state, while giving A plus indicates these two are important at the same time. That is nothing but two choices we have. So for the two choices of input, it is reaching the final state. So that I can write it as a, so one initial state and one final state. So here we need to give two input values. So two input values I am giving as A as an input symbol, it is reaching the final state. And also if you give B as an input symbol, it is also reaching the final state. And coming to the AB. So AB is also only AB value is there, and we need to write it as a, so here after giving the A as an input symbol followed by B here. So A is followed by B here. So how many minimum length is 2 here, and we need to write it a further 3 states. So that I am writing initially I have a Q naught symbol, and first step is as a input, it is going to reach the Q1. For B input symbol, it is reaching the final state, QF. So it is reaching the final state. So in between there is only one string is there, so no condition is there. So only AB should be satisfied. For that, how to design the finite automata? So A is followed by B here and reaching the final state. And for A star, so A star, it is having the set which is having epsilon symbol, A comma A and so on. And for this one, what is that? So initially it is having the epsilon symbol here. So epsilon symbol is nothing but this epsilon symbol, it is reaching the final state, and also with the input symbol A. So how many times A is repeating? So for the A, we need to write it as it is reaching the final state with the A input symbol. And also this final state which represent the epsilon symbol also, so that the first condition is satisfied here. So here epsilon, along with the epsilon, this A is also how many times it is repeating. There is no other states are involved in this A star. And A plus. So here A plus, which indicates A comma AA comma triple A and so on. See here we have the A here. So here A plus A star is there. This is A star, and what is the difference between A plus is nothing but, so this epsilon is included here. There is no epsilon there. So no epsilon in the sense the first state is not the final state. So first state is not the final state in the sense we need to give initially 1 as an input symbol to the one state, and it is reaching the final state. So this is reaching the final state with the A input symbol, and here how many times A is repeating? It is in the final state only. So this is the A plus. So what is the difference here? So A star indicates that's initial state, it is having the epsilon as an input symbol and also A as an input symbol repeatedly. And here coming to the A plus, so initially this A is compulsory, it should be there. So first one is to satisfy in the, so first one you need to satisfy in the figure, in the transition diagram. So that later how many A's are repeated, that will be written as a loop in A. So this is about the A plus. So what we have a regular expression, as these are all examples of regular expressions, and we converted it to a finite automata. I'll take one more examples. So A plus B whole star. So A plus B whole star indicates, so here A plus B we already have. So A plus B, so A plus B is equal to Q naught. So first we need to write initial state, and so for the input state, two input symbols we need to give as a next state. So QF, so final state is there. So and for A plus B, so here there is no initially, so A plus B there. So here A plus B indicates two options which are equal to the final state. So here which is having the epsilon also, epsilon as in also input symbol, and also it is reaching the final state, and with the two input symbols. So there is no state we need to take as a one more state here. Why? Because the two inputs which are having the final state representation, so that it will be A plus B is represented like this, and A star B star. So here A star B star is nothing but we need to, A is followed by B. So here, so A star is there and B star is there. So two things are there. So here example of language which is having epsilon also. So that epsilon in the sense the first step, first one is final state with the epsilon symbol, and also for the input symbol also it is we have a two values here, so we can't write two values for the two final states. So that I am giving epsilon as an input symbol, it is also reaching the final state, that is QF. And here we have A star is followed by B star, so that A star is satisfied. So here A star it is having the epsilon symbol as an input symbol, and B star it is also having the epsilon symbol as an input, and here we will write it as A star B star. So with the epsilon input symbol, it is reaching the final state. And coming to the AB star. So AB star is nothing but we have the final state here. So Q naught and Q1. So here A is followed by B. So here A is followed by B. So we will write it as A, and B which is followed, and with the A, B, it is reaching the final state. Why? Because initial state is final state in the sense the epsilon is there, so epsilon is the starting, and AB, how many times it is there? AB, and so on, and so on. And so that first whenever the star is there, first initial state is a epsilon, initial state is a final state. So that for this one I am writing A, and one more state we are taking, and for the B, AB input symbol, it is reaching the final state. So that this is about the AB whole star. And next, A star B. So A star B is nothing but, so we need to take them A, so A star, so Q naught and Q1. So it is reaching the final state. So that B, so when we reach the B only, it is in the, when we reach with the A input symbol, so here epsilon is there as an input symbol, so A star is satisfied here, and followed by B. So the next input B only, we have to be, B should be must and should for the final state. So that's why I am writing as a B as an input symbol, and it is reaching the final state Q1. So this is about the A star B. A star B representation, and here A followed by B star, so that A star B followed by, here the thing is for the final state B is an input symbol. So how to write this one? So Q1, so A as an input symbol, it is reaching the final state. Why? Because the epsilon is also included, QF. And here the B as an input symbol, it is reaching the final state. So these are all about the irregular expressions to finite automata. And we are any regular expression, these are all the without operations. Suppose here the lengthy symbols, which is having the plus symbols or concatenation operation is there, we need to draw the step-by-step process, how we will see. So these are all examples, and here we have taken the two more examples to express the regular expressions to finite automata. So here the finite automata. So here initially we need to divide this according to the plus symbol. So here the plus symbol, which is separating with the two choices. So here what we can say, so Q naught as an initial state and Q naught as an initial state. And for the two choices, it is going to the final state. So one choice is 0 star 1 and second choice is 0 1. So here one choice is 0 star 1 and second choice is 0 1. So we need to do, in between we have the concatenation operation is there. So concatenation in the sense, this 0 star is followed by 1 and 0 is followed by 1. So here we will write same thing as a Q naught, and first we will take upper part. So in this one two values are there. So in these two values we have 0 star 1. So 0 star indicates it, initially we can write it as a without epsilon symbol, without giving epsilon symbol, we will take it as a Q naught 0 star. And for one input value, it is reaching the final state, that is QF. And also we have 0 1 is there, so that I will include one more state here. One is Q1, and here initially 0 and followed by 1, it is reaching the final state. So this is about the 0 plus 0 1 0 star 1 plus 0 1. And for this one we need to write, so initially Q naught is the initial state, and also we have two choices here. So two choices is, one is 1 0 and it is reaching the state, final state QF. So QF is a final state here, and for the one more input symbol is 0 plus 1 1 0 star 1. So here 0 star 1. We have two things, two input values, so that for the two inputs. So and upper part I will write it as a q naught. It is 1 is followed by 0. So 1 is followed by, I will just include one more state here, that is not 1, and we have the 0, and it is reaching the final state. And here we have a concatenation operation. So in the concatenation operation, we have followed by, all are followed by, so 0 and one more. So 0 plus, this I will write it as a q2 and q3, and so for here I will take it as a 0 plus 1 1 and 0 star and 1. So directly we can write this 0 star without epsilon symbol, so that I don't need to write the q3 value. So here, so q naught, so which is having 1 as an input symbol and q no 1 and 0 as an input symbol, it is reaching the qf, and here 0 plus 1 whole star. So it is having the epsilon symbol. Without writing epsilon symbol, I can write it as a 0 self state and with the 1 input symbol, and here 0 plus 1 1. So this 0 plus 1 1, again we have two choices here. So we will write it as here. So q naught is the initial state and q1 I am taking as an input, and for 1 input symbol, and for 0 we need to write it as a qf, and for 0 plus 1 1. So 0 plus 1 1, it is a two choices. Either it can reach with the 0 or 1 1. So it is reaching the final state. So that, so I am writing here q2. So q2 with the 0 input symbol, self and 1. And also we have one more thing. So here 1 1 is there. So 1 is followed by 1. So 1 is followed by 1 in the sense we need to write it one more state here. So directly you can write here. So q naught as an initial state and q1 and qf. Here one more state is there, q3, and this one is there, and the 0 and for 1 input symbol, so q2 and with the 0 input symbol and also with the 1 input symbol. So 1 is there, 0 is there, and here I need to directly write, so 1, this is here 1 is followed by 1. So here whatever there, here this is the final state. So here how we are representing the regular expression to a finite automata. First step is we need to divide according to the choices, like plus indicates, so this with this two options we can reach the final state, and then we need to divide that according to the star and concatenation operation and with the plus symbols. So this is about the regular expressions to finite automata. And here we will discuss about the finite automata to regular expression. So here finite automata to regular expression, we need to convert the regular expressions like first we will take a plus b. So we already discussed in the previous slide. So how to represent the regular expression to a finite automata. And now we are taking a finite automata and we will convert it to a regular expression. So first one is a plus b. So for a plus b, we will write a q1 and giving a, it is reaching the final state. We have two options. For two input symbols, it is reaching the final state. So that is nothing but, so qf, so this which is equal to a plus b. So this is a regular, this is a finite automata and this is the regular expression. So two types here we have finite automata. When we are giving as an input as a finite automata, we need to convert it to a regular expression. This is simple example of finite automata. Let me take one more example. AB's so initially q naught as an initial state and also a final state, with the two input symbols. So A as an input symbol and Q1 I will take and B as an input symbol. So this represent, so final state is a initial state and final state are both same. So that indicates how many times it is, and also epsilon symbol is there. And also we have AB symbol. So A is followed by B and it is reaching the final state. So that A is followed by B, it is reaching the final state, and how it is loop. So that I can write the epsilon star symbol. So the star indicates sigma and AB, ABB, AB, AB and so on. So this epsilon is satisfied with the initial condition. So initially it is having the epsilon symbol as an input symbol and it is reaching the final state. And this is the second example, and third example we will take it as A. So initially we have a Q naught symbol. So Q naught symbol, and which is followed by BAB. So which is followed by, so Q1. So Q1, which is A is input symbol, and B we have to write it as a. So we already saw AB star. Now we will check for A, B. So final state is here Q1. So we just changed the final state. So previous example, which is the Q naught is an initial state, and here Q1 is the initial final state here. So for this kind of finite automata, how we will write the regular expression? So Q1 is the final state here, and here A is followed by A is reaching the final state. So with the A input symbol, it is reaching the final state, and also multiple times. So whenever it is reaching the A is reaching the final state, it is the first one, and with also one more input. So B is there, and B and A. So we can write B and A, and also it is reaching the multiple times. So with the B is followed by A, it is reaching the final state, and also multiple times to the final state, that is nothing but a star. So A is reaching the final state. So let me write this language. So this initially A is there, and how many epsilon is also input symbol is there. So epsilon with the BA, so that is nothing but only epsilon. So only we have A symbol. And also how many BAs are there, we need to write it as a BA and BA like that. So we can satisfy with this regular expression. So B is followed by A now, and it is reaching the final state, and with here example BA and with the A input symbol. So this is about the third example of finite automata. And now we will take the fourth finite automata. So with the finite, initially we have a final state, that is nothing but Q naught, and we will take Q1 as an initial state, and we are just changing the values like initial and final state. So final state is for the same how to show the differentiation between the only two states with the two input symbol. And here with the we'll take one more input symbol. Here A is I am taking, and we have the value B and C here. So B and C here. So here how to design the regular expression for this finite automata. So initially initially Q naught is the final state with the A input symbol. So what that indicates, A star, and B is followed by C, which is reaching the final state, that is a BC, that is BC whole star. And here we have two options. So one is A star, it is reaching the final state, and BC, it is also reaching the final state. So that I can write it as a simplify this one, A plus BC whole star. So according to the identifiers, so identify as R star plus R star is equal to R plus star, like this. And this is about the fourth example. And fifth example we will take. And here we changed the values and we are just included the one more input symbol here. And we will take one more example as a initial and final state. So initial state we will take it as a Q0, and next Q1 as a final state and with the same input symbol. So here A as an input and B it is reaching the state and C it is reaching the initial state. So how we can represent this with the regular expression? So here A is reaching the final state here. So that A and B with the B star and multiple with the B star plus CA followed by CA, and also it is a unit symbol. And here A is the input symbol and B is the, so here A with the along with the A input symbol we need to write it as a B star plus, and also it is reaching the multiple times we can write it as a whole star. So initially whatever there we are loop it is reaching the final state, so that so this final state which is represented as a whole star I will write it as a, and now we written like this: A star plus B star is equal to A plus B whole star. So B plus CA whole star. So it is after simplifying the regular expression, we got the string, we got the regular expression like this. So this is how what we have taken. Only we have taken the two states and we just changed the final state and initial state values and with the two or more input symbols. So this is how we are designing the regular expressions from the finite automata. And here we will take two more examples. So here the Q0 is there and Q1 is there and Q2 is there. So this is Q2 is the final state. So how can we write this 1 star? So why? Because with the epsilon symbol also 1 is repeated more time and with the followed by 0 and which is having the input symbols 0 plus 1 whole star. How we can write this one? So 0 with the 2 input symbol it is reaching the final state. So 2 input symbol in the sense 2 A plus B. So with the A input symbol or B input symbol it is reaching the final state. So with the A input symbol and also with the B input symbol it is reaching the final state. Without writing this Q0 we can directly write it as a comma B here. Like that C 0 1 is there. So this 0 1 is included like this. So here 1 star 0 and 0 plus 1 whole star. And coming to the second example. So here A star is there. So here A self loop we can write it as a star and B is followed by C. So B which is reaching the C final state with the C star and also we have the B. So how we can write it as this? So here AB C star C plus AB star. So here also we can write it as a, so A star. So is equal, first initially we have A star and we have B and C. C star it is self, it is having the value, and so with the A star symbol and BC star plus B A star C, B it is reaching the final state. So that I can write, so I will write it one more time. So A star B. So A star B it is reaching the final state, and also we have C star. Initially we have a B, we have B, sorry. So C star C star with the C star and plus B A star B, it is reaching the final state. So here both we have for the final state, and also we have the whole star here. So why? Because this is the final state with the self loop, so that we can write it as a whole star. So this is about the finite automata to a regular expression. So these are all examples of finite conversion from one form to another form. That is the regular expressions to finite automata and finite automata to a regular expression. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.